Number 6 and 7 says, another way to write radical expressions is with fractional exponents. We got the square root of 16 times the square root of 16 equals 4 times 4, which equals 16. If I wrote it as a fractional, it says use the definition of a radical and the properties of the exponents to simplify the expression in each row of the table. The first row has been done for you. Says 16 to the 1/2 times 16 to the 1/2 equals 16 to the 1/2 plus 1/2, which is 16 to the 1, which is 16. All right, what's the cube root of 8? 2. What's the cube root of 8? 2. What's the cube root of 8? 2. To write it as a fractional, it would be 8 to the 1/3 times 8 to the 1/3 times 8 to the 1/3. Oh, sorry, I should have simplified this. This was 8. Well, that would be 8 to the 1/3 plus 1/3 plus 1/3, which simplifies to 8 to the 1, which is simply 8. The fourth root of 81 is 3. And 3 times 3 times 3 times 3, that's 9 and 9, that's 81. So we did a fourth, a fourth, a fourth, a fourth. So 81 to the 4th plus a 4th plus a 4th plus a 4th equals 8 to the 1. 81 to the 1, which is simply 81. Lastly, we have the square root of a times the square root of a. Well, the square root of a times the square root of a is simply a. Because a to the 1/2 times a to the 1/2 would be a to the 1/2 plus 1/2, which equals a to the 1, which is simply a. Identify and describe any patterns in the table. Write a to the 1/nth power as a radical expression. Well, it looked like whatever was in my denominator position was my index of my radical. So we would write this if it was a to the 1/nth power. N is my radical, my index, and it's going to be a to whatever this numerator position is. So a to the 1 cube, nth root of, so these are the same thing. The general rule for a fraction, on to the next section.